The unit normal z-score table lists relationships between z-score locations and proportions in a normal distribution. If you know the z-score, you can look up the corresponding proportion. If you know the proportion, you can use the table to find the specific z-score location. The p we use in the notation can be equally applied to mean proportion, probability, or percentage, depending on what the problem calls for. Let's practice with the graphs on the slide. In the upper left, we want to answer the question, what is the probability of selecting a z-score value greater than z equals 1.00? Open your book to the z-score table that starts on page 571. The first step is to locate the z-score of 1.00. We want to find what proportion of scores the shaded area represents. When you need to find the proportion of scores, starting with a z-score and going towards the tail, you go to the tail column. You should correctly find the value of 0.1587. For the top middle graph, we want to answer the question, what is the probability of selecting a z-score value less than 1.50? Here, the shaded area constitutes more than 50% of the area under the bell curve, so we would go to z equals 1.50 and look in the body column to find the correct value of 0.9332. In the top right, we want to answer the question, what proportion of scores are less than z equals negative 0.50? We would find the z-score of 0.50 and again consult the tail column to find the proportion to be 0.3085. Sometimes we work from the inside out in the z-score table, and that is how we will work the problem in the graph on the bottom left. The question we will start out with is, what is the z-score that separates the top 10% of scores from the bottom 90%? Think about where that z-score on the graph is located. It is on the right, the positive side of the scale, and the shaded percentage of scores is in the tail. To solve this, go to the z-score table and look down the tail column, column C, until you find a proportion as close to 0.1000 as possible. That is 10% converted to a decimal point format. As you look down that column, you will find that the closest value there is 0.1003, and it is associated with z equals 1.28, which is our answer. Notice that it is a positive 1.28 because it is on the right side of the bell curve. For the next problem, our task is to identify the z-scores that form the lower and upper boundaries of the middle 60% of the area under the curve. The way we will solve problems like these is to draw an imaginary line right down the center of the curve, right where you would locate the mean, so that you have two equal halves. What you have just done is split that middle 60% in half so that you have 30% to the left of the mean and 30% to the right of the mean. Now you can easily solve the problem by going to the mean to z column, column D in the z-score table, and finding the proportion value there that is closest to 0.3000. When you get to the values closest to 0.3000, you find that one value, 0.2995, is 5 points below the target value, and the other value is 0.3023, which is 23 points above it. So the closest value to 0.3000 is 0.2995, and it is associated with z equals 0.84. Thus, the lower and upper z-score boundaries that frame the middle 60% are plus and minus 0.84.